Okay, so this lesson is going to be about the formulae that we use with arithmetic, sequences, and series. Very quickly, just a reminder that arithmetic means the same thing as linear. So in an arithmetic sequence, each term, each pair of terms have the same difference between them. Has the same difference from the one before. So we've called those sequences in the past linear. We're going to call them arithmetic from now. It's just another version of the vocabulary. You might be wondering, what's the difference between a sequence and a series? Well, we talked yesterday about sigma notation, and a series just means the sum of a sequence. So I'm going to tell you a little story before we start about a mathematician called Gauss. Gauss is a German mathematician after whom numerous things are named, perhaps most famously the normal distribution curve you may have seen. It's called the Gaussian curve. And when Gauss was a little boy, much younger than you are today, way back in the 18th century, he was quite a precocious child. And his math teacher was fed up with him getting the right answer all the time. And so he said to him, Gauss, people used to call each other by their surnames back then. He said, Gauss, add up all the numbers from 1 to 100. And his math teacher, the boy's like 11 years old. His math teacher's thinking that's going to take him a little while to do. But Gauss, more or less immediately, comes up with the answer, the correct answer, 5,050. So how did he do that? Well, this is what he did. He said, well, if I'm adding all the numbers up from 1 up to 100, then there's obviously some sort of pattern there. So what he did was he said, well, we'll call that S, say, and we'll do it again, but the other way around. All the way down to 1. Now what's clever about that, well, Gauss realizes that what he's really doing is he's pairing the numbers up, and his pairs all add up to 101. All the way down to the end. And there was 100 numbers, so there's 100 pairs of numbers. Now, there's 100 of them, and they're all 101. So 2s is got to be equal to 100 times 101, which I should imagine you can do in your head is 10,100. Now obviously we've counted the sum twice there, so to get the original total, just add in 1 up through 100, we just half that, and that's where we got his 5,050 from. So we're going to use a similar technique to that to find a way of easily adding together arithmetic series. And it works like this. We've got an arithmetic series, and it starts with U1. And every time, every subsequent term, I'm going to add D. Why D? D for difference. Why U? I don't know. So U1, the second term will be U1 plus D. The third term will be we add D again. So that'll be U1 plus 2D. Same thing again, U1 plus 3D, and so on. So the nth term in that sequence is not U1 plus ND, because in the second term, remember, in the second term here, we had 1D. In the third term, we had 2D. In the fourth term, there were only 3D. So in the nth term, there won't be ND, but there'll be n plus 1D. N minus 1D, sorry. That's the nth term in that sequence. So let's say I wanted to add up all those terms, the n of them. We'll call that Sn. So if there was 50 terms, it'd be S50. If in the example we did before there was 100 terms, then that'd be S100. And we do it in exactly the same way like Gauss did it. We say we've got U1 plus U1 plus D plus U1 plus 2D Before I go any further, I'd like you just to pause the video. If you've not understood anything, it's a chance to go back and review it again. But more importantly, I'd like you to see if you can work out what the formula for Sn would be by doing something similar to what Gauss did, by flipping the sum around. Okay. Hopefully you've done that, so I'll just very quickly shoot through that. If we write it out again, the sum, but flip it around in the opposite order. And that one, obviously that one will be u plus n minus 1d, and the last term will just be u1. The term before that, sorry, the term after this un plus n minus 1d will be one. There'll be one fewer d. So instead of n minus 1d, we've got n minus 2d. Next one will be n minus 3d. And so on down to u1. When you add those two things together, you get two lots of Sn. And that's equal to, we've got u1 here, u1 plus n minus 1d, so that's 2u1 plus n minus 1d. Now if we've done it correctly, then when we pair these ones up, we should get the same thing. This one and this one. Well, what do we got? We've got 2u1s again, and we've got n minus 1d, because we've got n minus 2 there, and one more, and so on. All the terms end up being exactly the same, all the way down to the end, where you see we've got u1 there, and u1 there, and n minus 1d again. How many of those terms have we got? Well, we've got n of them. Right, n terms. So what we've got for our 2Sn is I've got n lots of 2u1 n minus 1d. Of course, I don't want a formula for 2Sn, I want a formula just for Sn, so that's half of that. N over 2, so it's 2u1 n minus 1d. And that formula is one you'll find in your formula sheets. Okay, what I'd like you to do just as a super quick exercise before we tackle the work in the book is I'd like you to take this sequence, 8 plus 11 plus 14 plus, what would be next, 17, all the way up to, let's say, 29. And I'd like you to identify what's U1, that should be easy, and what's D. A little bit harder is what's N. And then you can use this formula oops, I've forgotten it for a moment there. Use that formula and you should be able to tell me what all those numbers add up to without having to type them all into your calculator. Good luck.